All right, so we've been working with similarity in triangles, and now what we're going to do is come up with the minimum requirement in order to say that triangles are similar. Now, we already know about SSS, SAS, ASA, side, 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 angle, side, angle, angle, side, hypotenuse, leg. Remember all those? Those are the criteria for proving triangles to be congruent. Congruent, that means same size, same shape. Now we just want triangles to be similar. Same shape, different size. Remember, for similarity, the sides need to be in proportion and the angle measures remain the same. Now, do we need to know that all the angles are the same? Well, not necessarily, because if you think about it, and I'm under here this AA criteria, that's angle, angle. It turns out that angle, angle is enough. You don't need angle, angle, angle. You don't need angle, angle, side like we do for congruency. You just need angle, angle for similarity, and here's why. Let's say this angle here was 100. Okay, well then this angle would be 100, right? Let's say that was 100 and that was 100. And then I knew this angle here was 30. And I knew this angle here was 30. So that's all I know. I don't know any sides. I just know 100, 130, and 30. It's all I know. Well, so that's angle, angle. That would be angle, angle right there. All right? Angle, angle. Similar to angle, angle. Okay? Now, I don't know angle C and I don't know angle N. However, what do we know about the angles of a triangle? They all have to add up to 180. So as long as I know two angles, I do know the third angle. So angle, angle is really angle, angle, angle without actually showing the third angle. But you would know that if this is 100, this is 30, this would be 50. And if this is 100, this is 30, this would be 50. That's why it's not necessary to prove the third congruent angle. So, in order, if we want to prove that triangles are similar, or if they ask us, are these triangles similar? As long as you know two pairs of congruent angles, you are guaranteed similar triangles, because 2 means 3, and we already know that 3 pairs of corresponding angles mean similar triangles. We've talked about that already. Another way to do similar triangles is to have nothing to do with the sides. Have nothing to do with the angles. Say I don't know any angles at all. I don't know 30, I don't know 50, I don't know 100. I don't know any of these angles, A, B, C, M, N, P. I don't know any angles. However, I do know that, and this is wrong here. This is a typo. You got to fix this. This should say PM over AB equals PN over AC equals, let's see, PM, AB, so PM, AB, and then PN, AC, and then it should say MN over CB. MN over BC. Over BC. That's a typo there, guys. This is what it should say for the given here. So if I know this, if I know that the sides are proportional, all 3 sides are proportional. So I'll give you an example with numbers. That's what I'm using this for. Let's say AB was 2. And let's say BC was 3. And then AC was 4. Just making that up, right? If I knew that, so AB corresponds to PM, right? So if I knew PM was, say, double AB, that would be 4. And then AC goes to PN. So AC goes to PN. So if PN was 8, right? And then BC goes to MN, so this would be 6, right? Double. So see how 2 went to 4 and 3 went to 6 and 4 went to 8. They all doubled. 2, 3, and 4 all doubled to 4, 6, and 8. If they all are in the same ratio, okay, then we know for sure that the triangles are similar. So that's called SSS criteria for similarity. This is called SSS similarity, not congruence. Different from SSS congruence. SSS congruence means this side is congruent to that side. They're the same length. this side is the same length as this side. They're the same length, okay? We are not talking about congruent, just proportional. If the sides are proportional, the same ratio, then I have SSS similarity. Back up here, this one was AA similarity. This is SSS similarity. The last way to prove triangles similar is SAS similarity. Again, this is different from side angle side congruence. I don't need congruent sides. I just need two pairs of proportional sides, with one congruent angle. So if I know angle A is congruent to angle P, right, that's given, and I know that the surrounding sides, the sides that make up those angles, are proportional. So if I know that PM is to AB, so let's say this is, again, this is 2 and this is 4, and then PN and AC, so if I knew this was 3 and this is 6, right? So I know this doubled and this doubled. So I know they're in proportion. They both doubled. They both did the same exact thing, right? They both got multiplied by 2. And I know the angle is congruent, one angle. So you can get away with one angle and proportional sides, and that gives you similar triangles. All right, so we would say triangle ABC is similar to triangle PMN. Now, we're going to call it different scenarios in these examples, and we're going to be asked to figure out if these are similar or not. So, first example, and I'm just going to tighten up my pen a little bit here. All right, so they gave us two triangles here. You don't even need the sides. You just need the angles. I have 44.42 and 57.12. You know the three angles of a triangle add up to 180. So we got to do a little bit of math. I did it ahead of time just to save time on the video for you. All right, so I have that here. All right, so I added these guys. I added those up, and I came up with 101.54. Okay, so I added those and I got 101.54. Now we know the three angles of a triangle add up to 180. So I did 180 subtract. Okay, subtract 101.54 and I got 78.46. So 78.46 is going to be this angle right here, 78.46. Right there. And then I do the same thing here. Add these up. Change colors. Add those up, subtract from 180. I came up with 44.42. 44.42. So let's take a step back, take a look at our triangles now. Get rid of the circles and everything. Let's circle congruent angles. I got 44.42. I got 44.42. I got 78.46, I got 78.46, and I know if I have 2, I must have 3, and of course I do have 57.12. But that's called angle, so I'm going to say by angle similarity, I know that triangle, I know that they are similar. These triangles are similar. Okay, and again, just the squiggly is similar. Okay, so by angle, I could tell they are similar. Are the triangles shown below similar? Explain. If the triangles are similar, identify any missing angle and side length measures. Okay, so we're gonna skip the side. Well, we'll do some side length, I guess. We'll do one of them. All right, so I have 95 and 25. So if I have 95 and 25, that's 120. This has to be 60. And then I have 24 and 95. And that leaves 61 left over. So are these similar triangles? Well, we don't have angle, do we? If we don't have angle, we can't have similar triangles. So no, only one pair of congruent angles. See, we did have the 95, right? We do got the 95, but we need another pair of angles in order to be similar. So, no, not similar. Only one pair of angles are congruent. That's the reason why they are not similar. And then they want us to find the missing side lengths. But because we don't do that because they're not similar triangles, so we can't actually find the missing side lengths unless we know they're similar or congruent. Number 3, given the diagram to the right, we have UX is perpendicular to VW, so I know I have a right angle here. Oh, that's the wrong one, but I know I have a right UX and VW. I have a right angle right there. And then WY is perpendicular to UV, so I have a right angle right there. Show that these triangles are similar. So what I'm going to do is I'm going to draw them separate. I'm going to pull these triangles out of the picture. I have WYV, and I have UXV. Okay, let me do blue here, just so I could show you. WYV. All right, so WYV, that's this guy right here. Okay, with that right angle we already know. And then UVX is this guy right here. You see how I did red and blue? It helps a little bit. See how they share the angle V? They both have angle V. So angle V is congruent to angle V. And these are both right angles. The X and Y are both right angles. When you pull them apart, you could see it. And look what we have here, guys. We have angle, congruent to angle. So yes. So say, so we have a shared angle V and right angles. Therefore, I'll play thus similar by angle similarity. Okay, so those are similar there. This one here, we just got to check the sides are proportional. We got the angle. We got our angle, so we could do side angle side, perhaps, okay? But we got to check the proportions. So we're going to go small to small and big to big. So we're going 1.565 over 3.13 equals 1.5 over 3. We have to see question mark. We have to see if they're equal. If those ratios aren't equal, we don't have a proportion. Ratios have to be equal to be a proportion. How do we check? We're just going to divide them. Take your calculator and divide these. If you divide these, you get 0.5. And if you divide these, you get 0.5. Does 0.5 equal 0.5? Yes, it does. So I have proportional sides. Two pair proportional sides, and I have a congruent angles. So I have side angle side similarity. Yes, similar. By side angle side similarity. Okay? I have the proportional sides and the congruent angle in between them. Just proportional sides, that's all you need. Go a little quicker here. I know you're like, oh man, this is long. We'll get through it. So this here now, because I have congruent angles here, guys, that means DE and BC must be parallel, because when you have, those are called corresponding angles. And if I have parallel lines, I have another transversal over here, so I must also have congruent angles here. See that? So I have two pair of congruent angles. So again, triangle AED is similar to triangle ACB by angle similarity, because I have corresponding angles, and I showed that here. This one here, we got to check for proportionality. So we're going to do small to small, big to big. So we're going to go 1 to 3 equals 3 to 5. Is that a proportion that works? Well, this is 0.3. when I divide 1 over 3. And this is 0.6. 3 over 5 is 0.6. Does 0.3 equal 0.6? No. See, the problem is sometimes we add. We say, oh, 1 plus 2 is 3, and 3 plus 2 is 5. You can't add to these sides to make them proportional. It needs to be multiplication. So if they don't divide out equally, then we don't have similarity. So this is no, sides aren't proportional. Sides aren't proportional. We did have the congruent angle. See that? We did have our angle, but we don't have proportional sides. So we do not have similar triangles here. Number 7, are they similar? All right, so we got to do a proportion. Now, they gave us all the sides. So we're going to do our proportion. Small to small. I did this ahead of time for you. Medium to medium. Large to large. Biggest to biggest. Do all those, they all have to be the same ratio, are they? Well, this is 0.75 if you divide them. This is 0.75 if you divide them. And this is 0.75 if you divide them. So you see how they all equal 0.75. So that shows we have proportional sides. So sides are proportional. Are proportional. So these are, triangle QPR is similar to that's a triangle, to triangle YXZ by side similarity. They are similar by side similarity. Last one here, guys. And this is going to be a side angle side because we got the vertical angles. So I'm just going to write that out. Vertical angles. If we had to explain this on an exam, you would be detailed as much as you possibly could. You would say vertical angles, angle AEB is congruent to angle DEC. And then we got to check the proportions. 2.24 is to 4.48 as 3.16 is to 6.32. And that is 0.5, and that is 0.5. They're both a half, right? They are equal, so the sides are proportional. Therefore, I do have side angle side. So this is side angle side similarity, and I could say triangle AEB is similar to triangle DEC. Again, that's by side angle side similarity. All right, those are your examples. We'll do more of this in class tomorrow. See you then.